Hello, once again, this is John Pilabaon, a BSEE student of FINMA COC, and today we're going to answer our P3 exam, which is the given question is to find the equivalent current, the equivalent voltage, and the base voltage, the current, I, the VC, and the overall voltage gain. Also determine the output collector voltage. So, first we need to get some highlighter. And now, this is going to be our main circuit. And we need to get the DC equivalent of this and the AC equivalent. So, now, to we will going for our DC equivalent, we're going to apply the Thevenin's theorem and the Kirchhoff voltage law for our base emitter circuit. Now, this is our base emitter circuit, and for our solution, we will get the equivalent current, the collector current, and the emitter voltage and the base voltage. But before anything else, we need to get the Thevenin's resistance and the Thevenin's voltage in order to get these values. Now, for our Thevenin's resistance, R1 multiplied to R2 over R1 plus R2, and which is the values are 47 kilo ohms, 10 kilo ohms, 47 kilo ohms, and 10 kilo ohms. And we get the value of our Thevenin's resistance, which is 8.25 kilo ohms. And for our Thevenin's voltage, R2 over R1 plus R2 multiplied to our VCC, and that is equal to 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms multiplied to 10 volts. So we get the value of 1.75 volts. So we already get the Thevenin's voltage and the Thevenin's resistance. Therefore, we can now get the value of our IE, which is equal to Thevenin's voltage minus base emitter voltage over the emitter resistance plus the Thevenin's resistance over the DC equivalent beta. Now, our Thevenin's voltage is 1.75 volts minus the VBE, which is constant in this case, which is 0.7 volts over 940 ohms plus 55 ohms. So we get the value of IE, which is equal to 1.06 milliamps. And for our IC, that is approximately equal to our IE, which is also 1.06 milliamps. Now we get the value of our emitter voltage, which is emitter voltage is equal to emitter current multiplied to emitter resistance 1 plus the emitter resistance 2, which is equal to 1.06 milliamps since our RE1 and RE2 is the same. So we just added them up. So we get the value of 940 ohms. So the value now of our emitter voltage is 1 volts. For our base voltage, that is equal to VE plus 0.7 volts. And that is equal to 1 volts plus 0.7 volts. So we have the value of our base voltage, 1.7 volts. For our collector voltage, that is equal to VCC minus IC times RC. And for the values, 10 volts minus 1.06 milliamps multiplied to 4.7 kilo ohms. So we get the value of our collector voltage, which is 5.02. So now we already get the values for our DC equivalent. So now we will able to to solve our AC equivalent. So for the AC equivalent circuit, this is gonna be our frame, and we will start with our solution. So the first thing we need to do is to get the equivalent resistance of our total equivalent resistance of our capacitors. So we have 25 millivolts over equivalent current. So we have 25 millivolts over 1.06 milliamps. So we get 23.6 ohms for our total equivalent resistance of our capacitor. So next is we need to determine the attenuation in the base circuit. So that is our R in total, or total input resistance is equal to, which is our R1 is parallel to our R2 and also parallel to our base input resistance. So since we don't have the base input resistance, so we're going to find first the base resistance. So the formula of that is the AC equivalent beta over multiplied to emitter resistance, total emitter resistance of our capacitors, plus the RE1, since as we can see, RE1 is in line with our total emitter resistance of our capacitor. So we have 175 multiplied to 494, which is the total of this one. So we get the base resistance 86.5 kilo ohms. And now we will be able to solve our total input resistance since we already get the base resistance. So 47 kilo ohms parallel with 10 kilo ohms parallel also with 86.5 kilo ohms. So we get the value of total resistance, which is 7.53 kilo ohms. Now, the attenuation from source to base. So we need to get the attenuation from source to base, and that is equal to source voltage over base voltage. This is also a input voltage over output voltage, and that is equal to source resistance plus the total input resistance over the total input resistance, which is equal to 600 ohms plus 7.53 kilo ohms over 7.53 kilo ohms. So our attenuation is 1.08. And now for the collector resistance, that is equal to collector resistance and RL over RC plus RL. So the values of that is, we need to remember that RC, we're going to need this collector resistance because we're going to solve our AV here, which is the voltage gain from the base to collector. So that is 4.7 kilo ohms times 47 kilo ohms over 47 kilo ohms plus 47 kilo ohms. That is equal to 4.27 kilo ohms. So we can already determine the voltage gain from our base to collector. So that is approximately equal to collector resistance over the RE1, and that is 4.27 kilo ohms over 470 ohms, which is equal to 9.09. So the total voltage gain from the base to collector is 9.09. Now, we will get the overall voltage gain, which is reciprocal of the attenuation times the amplifier voltage gain. So this is going to be the formula. Base voltage over source voltage over the AV, which is equal to 0.93 times 9.09. So we get 8.45 for our overall voltage gain. Now, so since the source produces 10 RMS, so we get the collector voltage, which is equal to the total voltage gain from the base to collector multiplied to our source voltage, and that is 8.45 times the 10 millivolts. So we get 84.5 millivolts. So we already satisfied the answers for the given questions here in our question. So the total collector voltage is the signal voltage of 84.5 millivolts RMS riding on a DC level of 4.74 volts. So for our answers today, this is all the equivalent. And thank you. God bless.